to speak. So with that, I'll say welcome everyone to today's class, and I trust we are all doing great. This class is expected to be a physical class. However, due to the fact that I won't be available for this week, I just wanted us to start. So by the grace of God, the next class will try and ensure that we have a physical class. So you're welcome to GPH 124, Introduction to Potential Field in Introduction to
Recording in progress.
You're welcome to today's class, GPH 124, Introduction to Potential Field in Geophysics. And it's a 2-unit course, and the lecture hours is expected to be 30. So I would just like to go through the course content with each and every one of us so that we have an idea of what we're expected to do. So this course will be taken by myself and Dr. Oladele. So I would start first the course, and as subsequently as we progress also, he's going to take some part of the course. So today's the course, we're expected to go through the overview of geophysical methods, and that would involve classification of geophysical methods, distinction between potential field and other methods, such as seismic and electrical, historical development and significance of gravity and magnetic methods, fundamentals of potential fields, concept of gravitation and magnetic fields, basic physical properties, mass, density, magnetism, then units and measurement scales. So that's the part I will mostly be taking. So we'll be looking at a general introduction of what geophysical methods are. It will just be like a refresher of what we have done before. And we'll look at the difference between potential field and other methods. Then in this course also, we are expected to look at the gravity method, where we'll concentrate on Newton's law of gravitation as applied in geophysics, gravity anomalies and their causes, types of gravity, a brief summary of what you're expected to do later as you advance studies in geophysics. So we'll just give a brief introduction of all of this. The magnetic method also would also be looked at. We'll look at the Earth's magnetic field and its components, magnetic properties of rocks and minerals, magnetic instruments, then application of potential field methods. So without much ado, we'll just start with today's class, and we're expected to look at the overview of geophysical methods. So this will be an interactive section. So I would like to ask, what do you think geophysics is? We did that last semester. So what is geophysics? Class, you have to answer me. Let me start calling your name. Aderemi Moses. Aderemi Moses. Unmute yourself and speak. What is geophysics?
Hey, ma'am.
Kindly note that I started grading you.
Good morning, ma'am.
Yes, go ahead. Yeah, good morning.
Yeah. Probably, yeah, mapping of physics, ma'am.
What do you mean with study of the earth with the application of physics? Does that make sense to you? Does the phrase that you have mentioned, does it make sense to you? The keywords are there, but you have not put them together rightly. So if I want to score you, I might score you a 6 out of 10.
Okay. Ma, is the study of the to know the
Go
Earth's
ahead.
physical properties and the structure, ma'am.
What did you say?
Ma'am, I think it's the study of the Earth using physics to know the Earth's structure and properties, the interior and the surrounding environment of the Earth.
That makes more sense. Thank you. Someone was raising his hand up. I think he could hear. Yeah. He could be Michael Olamileko. You are raising your hands. Yes, please go ahead. No. It's the only physical properties of the earth that we look at. Can someone else try? No, we are not getting it. This one is totally off. So if I want to score you, I will score you a 3. Yes, who else? All right, Timothy, please go ahead. Adjourn, Timothy, please go ahead. Adjourn, please go ahead. If you are speaking, we cannot hear you. Someone else was raising his or her hands. Timothy, if you're speaking, we cannot hear you. Joy, do you want to talk to us? Demilade Ajiga, please go ahead.
Good morning.
Good morning.
Geophysics is the application of physics to study the earth and its natural processes.
Thank you very much. This use of physical principles is very important. Use of physical principles to study the earth and its natural processes. So if you look at that definition, you notice that we have 2 keywords. We have the earth and we have physical principles. And if you look at what we are studying today, you remember potential field. You have studied the physics. There's different types of energy. You remember that. What kinds of energy do we have? What types of energy do we have? Can we remember? Can we remember, class?
Yes, ma'am. Solar, electrical,
mechanical, kinetic.
Kinetic, potential energy.
Yeah, thank you very much. That's what I wanted to hear. So we have in the classification of energy, we can have the energy that is potential and energy that is kinetic. So for kinetic energy, we are looking at energy as a result of motion. For potential energy, is the energy as a result, it happens as a result of rest. So all of these principles that we have learned. Also, if you remember in physics, we have studied gravity. In physics, we have studied magnetism. In physics, we have studied waves. And in waves, we remember we have different types of waves. We have both mechanical waves, we have, I think we have transverse waves, we have elastic waves, and so on. So all of those things that we have learned, all of those physics principles that we have learned, we'll be putting them into practice in geophysics. But now, in what we'll be doing is that we'll be using that physics principle now to study the Earth. So once we're talking about gravity, remember, if you're talking about gravity in physics, you might say that a rocket is propelled out of shape. What would be the gravitational attraction due to the Earth and all? So we might not be looking at the gravitational attraction of rockets and all, or things leaving the Earth's gravitational space. What we'll be looking at is the gravitational potential of Earth materials. If we're also talking about magnetism, we might not be talking about super magnets, all the kind of magnets, the magnetic properties of metals and all, but we'll be looking at the magnetic properties of rocks. If we're also talking about electricity, we might not necessarily be limiting ourselves to wires and all, but here we'll be looking at the electric properties of subsurface material of the Earth, okay, and how the various processes of the Earth affect these principles. This is the last time I'm going to warn anybody. If you are joining this call, please mute yourself. If you do not mute yourself, I will take you out of the class. So these principles, we utilize them to study the Earth. So once we're talking about seismic, electrical, gravity, magnetic, I expect us to pick up our physics textbook and go brush ourselves up in all of this, in all of these principles, such that when we're talking about it in geophysics, then you'll be able to make sense out of it. Because you cannot divorce yourself, or you cannot divorce the physics from geophysics. The physics has to be there, the geology also has to be there. And that's what we're doing. That's what geophysics is all about. And we have a classification of geophysical methods. And if we define or if we have been able to effectively classify geophysical methods, then we can once we clarify that, then we can be able to know what exactly we are doing with our geophysical method. So right now, what we'll be going into looking at, I'll have to ask a question. What are some of the geophysical methods that we have? Like 7 geophysical methods. Mm. 2. Please speak up. Speak up. Michael, speak up. Let me hear you. Okay. Mhm. Yes. Okay. We're in 4. Mm. Cancel. That's 5.
Electromagnetism.
Pardon? Electro what? Yeah, but the ground penetrating radar is part of the electromagnetic method. So, but I'll just take it. So let's assume that we have EM method. Okay. Which other method? Class, can we help him?
Remote sensing method.
What is remote
Remote
sensing
sensing
method?
method.
There's nothing like a remote sensing method. Okay.
I saw it inside one of the books I was reading. That's why I said so.
You have taken it out of context. Remote sensing, all geophysical methods are remote sensing. By remote sensing, it means you do not have to, or most, let me be very more careful. So most geophysical methods are remote, in the sense that when they talk about remote, you don't have to disturb what you're investigating. So most times in our investigations, we do not disturb the earth. So geophysical methods are actually remote sensing methods. So it depends on what you term remote sensing. So I will not take remote sensing as the method. Okay. Eh? Yes. Yes. Okay. So that's why I said the context matters. Okay, if you want to define remote, your remote is dependent on how far you are from your target. If I say Ogun State is remote, Ogun State cannot be remote if I'm living somewhere in maybe I'm living close to maybe Songo or something. So it depends on where I'm staying. If you are staying very far away from it, you say remote areas of that place, that means very far away. So the same thing applies. If you come to geophysics now, our methods measure or look into the Earth's subsurface. And the Earth's subsurface is about kilometers in depth. You can go to even 1 kilometers, 2 kilometers down the Earth. So if you're now taking measurements on the surface of the Earth, which is at 0 meters, would you not consider that as a remote method? Because if you want to actually take measurements at 1,000 kilometers, you are supposed to drill to 1,000 kilometers and take measurements. So geophysical methods, most geophysical methods can be considered as remote in the sense that they do not have to interfere with the ground. Your interference in terms of seismic, what you mostly do is, especially if you're using, depending on the source, if you're using a sledgehammer as your source, what have you done? You have not really destroyed anything. You are still imaging the subsurface remotely. So you cannot just say remote sensing method is a geophysical method. There is nothing like that. Do you know that remote sensing, when you talk about remote sensing, usually you have, maybe you can have a vehicle, like a space vehicle, like a satellite or like a drone that goes around the place to take measurements. Do you know that in all of these vehicles that are used for these measurements, you can have gravimeters, you can have seismometers, you can have a lot of physical instruments on all of these infrastructure moving around to carry out measurements remotely. So that is why I'm saying that you cannot define remote sensing as a geophysical method. Take note, that's where my concern is. Remote sensing is not a geophysical method. If you want to talk about remote sensing, you have to specify exactly what you mean. I can't ask you what are geophysical methods and you tell me remote sensing. That is incorrect. I hope that is clear. All right, so we are still left with one method. Should I leave that as assignment? So assignment 1 for class.
No,
Except
you need
somebody
to
gives me yes, success.
radiometric.
Thank you very much. Radiometric method. So radiometric method. So we've measured about 7 methods. So also have different types of electrical methods. We have self-potential, we have induced polarization. For seismic also, we have seismic reflection, seismic refraction. We have surface wave analysis. We have quite a huge range of geophysical methods that we can employ to study the subsurface. That is why I said the key word here is the use of physical principles to study the Earth. So recently, there has been a claim. I don't know if you guys have seen that claim. And in that claim by the scientists, they said they looked at the subsurface underneath the Giza pyramid. The Giza pyramid is one of the pyramids in Egypt that is of interest. So they said they used a particular method to study to look at the Earth's subsurface to get an image of what the structure in the Earth's subsurface underneath the Giza pyramid is or is. So if you look at that now, they have also used geophysical methods, that they have used physical principles. Initially, people thought that they used ground penetrating radar, and there was a lot of some reporters when they were reporting the research, they said scientists used ground penetrating radar to image the subsurface beneath the Giza pyramid. And a lot of scientists came out and said you cannot use GPR to do that, because the depth penetration of GPR is less than a few meters. And you cannot tell me you're seeing or getting a result of the Giza pyramid subsurface about 1 kilometers, which was about what they got. However, the scientists now clarified and said they did not use ground penetrating radar. They did not use that principle, that they used a principle called inter something spectrometer, Doppler effect, and all of that. Then if you look at all of these methods are things that we use to study in physics. So using any kind of physical principle to study the Earth, if they define that method very well, it now becomes a what? It now becomes a geophysical method. I hope that is clear. And give me some time, class. I'll join you soon. All right. Sorry for that breaking transmission, class. Hope you can still hear me.
Yes, ma'am.
All right. So just like that was what I was trying to tell you. Let me quickly just check. So I want our class to spur your interest in geophysics and not necessarily be limited by what we learn and what we have. These are pyramid findings. All right. All right. So I will just share. I want to share this with you. Please confirm you can see my screen and what can you see? Class, what can you see?
Egypt's Giza
Egypt's
pyramid.
Giza pyramids.
mystery.
Okay, all right. So this is reported by Economic Times. Egypt's Giza pyramid mystery deepens. Radar finds underground structures twice as deep as the Eiffel Tower, stretching across 2 kilometers. Okay, so you could just Google it and read it up. It's quite an interesting theory that they have here. So here you would notice that the researchers from Corrado Malanga from the University of Pisa and Filippo Biondi from the University of Strathclyde used the what synthetic aperture radar. That's so here when they initially announced their findings and just said they used radar, a lot of people just limited it to ground penetrating radar. And when they saw the 2 kilometer depth at which they propagated, they did the propagation, they were like, is that possible? It's not possible for GPR to go up to 2 kilometer based on existing theory and what we know about GPR. So they now clarified that they did not use ground penetrating radar, but what they used was what synthetic aperture radar. So you'll notice that for them now to be able to use this now to characterize the subsurface beneath these pyramids. First of all, you note that they are using this method, and number two, they did not drill at all. So just like I told you, this method is also a remote sensing in the sense that you don't have to perturb the subsurface, but you just study it. So we can classify this as a geophysical method if it is well defined and elaborated on, if we can use it to study the subsurface of the Earth. So once we can use any physical principle to study the Earth's subsurface, that we can classify as a geophysical method. So a lot of methods, giving this analogy, a lot of methods are actually being developed most times. Why is my page with? So you see the Khafre pyramid, the second largest structure on the Giza Plateau, was found to have 5 identical structures near its base. I want to try and look up the model the scientists got, the model the scientists got. You just see how amazing the ability for us to see the subsurface is. So what this implies is that if they have confirmed, or if we confirm, remember for any geophysical method, all you need to do is you infer. So the next thing that is left for anyone to do is to go ahead and probably drill. However, there's politics surrounding the drilling to confirm the results of the scientists. So let me say the new model of the Giza pyramid structure. So I encourage you to read and expand your knowledge. Okay, most of them are videos, so I don't have any images. All right, so this is what I want to share. Okay, I don't know what can you see, class? Can you see my screen?
Yes, ma.
Yes, ma.
What can you see?
Pictures of the new. Oh, you have switched your tabs.
Stop.
Recording stopped.
Okay, so let me share my screen. I just want to share something with you guys. So you can see, you should be able to see the pyramids now. Yes. So this now is the model of what they have done. So this is the pyramid. So they were able to look out for what is beneath the pyramid, in particular, the Khafre pyramid. So underneath, what is there? So from their model, they are saying that underneath this pyramid, you have these cylindrical structures like bars, like bars. I think there's a name for it that goes down to support inside the underneath the subsurface, and it goes up to 2 kilometers. You can see something of how they inferred it. This was from their data, the analysis of their data. So if you take a look at this, if you their videos are out there, so you could take a listen to it. You just see the interest that it gives you. So this method now, and this method, this is some of their tomographic images. So a tomograph is like a 2D image of the subsurface. So this is a 2D image subsurface they got, and from which they now obtained these models that we have here. Okay, I think we have digressed a little. So I'll come back to our study for today. So that's the geophysical methods, basically. So now we want to concentrate on potential field method. Remember, geophysical methods are quite enormous. So we need to define how do we define, or how do we classify them, and how do we further classify them into potential and non-potential field method. So generally, geophysical methods are techniques used to measure physical properties of the Earth's subsurface to what infer geological structures and materials. So they are broadly classified based on, so your classification is dependent on what the classification criteria. So if you are classifying it in terms of the physical property measured, and you just classify them as a broad range, you can classify it as gravity, magnetic, electrical and electromagnetic, seismic, and nuclear. So for gravity, you have anything that measures gravity, which would be normal gravity, microgravity, and so on. For magnetic also, anything that has to do with magnetic measurements. For electrical and electromagnetic method, you have resistivity, self-potential, ground-penetrating radar. Anything that is related to electrical and electromagnetic method is classified under that. For seismic also, anything that is related to seismic, to earth waves, elastic waves that flows in the earth, seismic, reflection, refraction, interferometer, and surface wave analysis, ambient noise, anything that has to do with seismic is classified under that. Then you also have nuclear also, where radioactivity might fall, proton recession methods, magnetic resonance can fall under that. So if you're just talking about the physical property measured, you can make that classification. If you're talking about the source of energy, I believe this was what it do some was talking about. When we talk about passive method, it uses the Earth's natural field. You don't have to measure, you don't have to put in your own signal source. You don't have to send in your own signal source. You measure what the Earth is generating. You measure what the Earth is emitting. While for the active, we are the ones that send signal. And we measure the signal we get to define exactly what we're doing. Then also we have measurement location. And this measurement location is where I was referring to, like remote and non-remote. So for surface-based methods, they can also be classified as remote measurements because you are not going directly into the subsurface to get the information there. So you have surface methods as well as borehole methods. So for borehole methods, we have some borehole methods like for radioactivity, you can drill and measure. Even if you drill, you can measure both the resistivity, natural gamma ray log, and a lot of measurements you can do using borehole methods as well as surface methods. So These are some of the classification criteria that are used. So I hope we are getting it. So to find out if we are in the same page, if I ask a question now, how many classification criteria can we use to differentiate or classify geophysical methods? What would you answer me? Okay. Thank you very much. I hope it is not only, thank you for answering. I hope it's not only Michael that paid school fees. Let me advise you, nobody paid your school fees. And whether you listen to the class, whether you don't listen to the class, you still have to write the exam. Whether you listen or you don't listen, you have to pass the course to be able to go for that and to be able to graduate. So my advice to you is that please participate in your classes, participate in the events of the school. If you're having a program, participate. Just in addendum, we have our former HOD, Professor Dukoya, that will be having her inaugural on the 23rd of July. I expect to see all of us at that venue. It doesn't make sense that you are coming to school and you do not participate in what is being done in school. It makes zero sense. I keep telling my students, the money that you are using to pay for school fees, if you are not interested in this course or if you are not interested in this program, just gather that money, go and learn one thing or go and start trading if it's better for you than wasting your time here. So what is worth doing is worth doing well. The idea of getting 30, 38, 39, and you'll be writing letter up and down does not make sense. So tell everybody our classes have started. Concentrate on your classes. Read your book. It's actually fun to read. It actually makes sense to read. It doesn't make sense that if you say you're an undergraduate in your physical program and they will ask you simple things and you'll not be able to answer. So please participate. You all paid the same school fees. Okay, so for geophysical method, we have some very major categories. Okay, when we are talking about classification based on physical property method measured, so we can have the gravity prospecting method, which measures variation in Earth's gravitational field caused by density contrast on the ground. We have magnetic prospecting. This measures the Earth's magnetic field due to magnetic minerals also present in the Earth's subsurface. Then we have electrical and electromagnetic methods. These are active methods, and they apply electrical currents and electromagnetic fields to measure resistivity or conductivity. It is worth noting also that we have some non-active electrical and electromagnetic methods. Such non-active methods include the self-potential method, and we also have the telluric method. So the telluric and the self-potential method are passive methods of electrical, that they are passive method under the electrical and electromagnetic method because we do not send in source in the subsurface. Then we also have seismic methods. Also under seismic methods, I need to mention, so for seismic methods also, we can have passive seismic. So passive seismic utilizes the Earth ambient waves, Earth ambient seismic waves. So we have, for those methods, we have methods such as the horizontal to vertical spectral ratio. We have passive ambient noise measurements and so on and so forth. But that's beyond your grade for now, but just take notes. Then we also have the nuclear methods, which measure natural or induced nuclear radiation from subsurface characterizations. So these are some of the categories that we have. Then we are expected to look at potential field methods. So the question you'll be asking, so which one is potential field methods? So generally, the potential field methods are measures, a method that for us to define it, we have it as it measures naturally occurring fields that obey the Laplace's equations.
So
who is that person that is on this call and making noise? If I get you, Let me just remove that person. You be in the class. You should not join the class if you know you are not interested in attending the class. You are not in the class. You are just joining. You are just joining for nothing's sake. Don't come and flog our attendance just to write attendance. If I get you, I'll just remove you from my class. So the definition for potential field method, it measures the naturally. Please take this note. It measures what naturally occurring fields that obey the Laplace's equation. So the question we'll now ask ourselves is, what is Laplace's equation? And the two methods that obeys the Laplace's equation are the gravity and the magnetic fields. And that is why the gravity and magnetic fields are classified under the potential field method, while other methods are classified under the general geophysical method. So here they use general artificially generated energy signals. And just like I told you also, we can have some of the seismic, electrical, and electromagnetic that are not natural, artificially generated. However, because they do not obey the Laplace's equation, we cannot consider them as the potential field method. So the energy source, usually for potential field measurement, the energy source is passive, while for other geophysical methods, you can have both active and passive. But for potential, it is passive. So examples are gravity and who is that mad person also? Who is that person that is making noise in our background and did not mute him or herself? I said you should mute yourself. You guys are refusing to mute yourself. Who is Badru, Opeyemi, and Ojo Daniel Finfolua? Please kindly mute yourself now. I give you a minute to mute yourself. If not, I'll remove you from this call. All right, so we have the gravity and magnetic methods as classified here. Then other methods apart from gravity and magnetic are classified as, are not classified as potential field method. Another thing we need to note is that their measurements. So we measure the variation in Earth's gravitational or magnetic fields. For the other ones, we measure what we have to measure, maybe transmitted signals or signals that generally are not general. Even if it is natural, it doesn't obey the Laplace's equation. Then density and magnetic susceptibility contrast. How do we apply it? So anything that has to do with density for gravity and magnetic susceptibility for magnetic contrast is what we utilize it for. Then other geophysical methods can be used for porosity, fluid contact, electrical properties, layering, and so on and so forth. So basically what I would like us to take out from here is that all potential field measurements, potential field methods are naturally occurring, and they also obey the Laplace's equation. Class, I hope I am clear.
Yes, ma'am.
So if I ask what is the key difference between the potential field method and the non-potential field method? Femi Johnson, I need an answer. Femi Johnson, I need an answer. Yes, go ahead.
Okay, the difference is
I'm waiting for you. I've not heard you.
yes. The difference is that
Are you sure Femi is in this class? So this is what we are saying. Are we sure Femi is in this class? Anyways, Williams, you wanted to answer my question.
I actually have a question, but I'll
Okay,
also
please.
answer the question now.
That's good. Please go ahead.
The difference between the potential field method and using geophysical method is
Order,
potential
mind
field
what you're
method is
answering. Always mind what you're answering and listen to the response you're giving. And that applies to when you're answering questions in exam. I'm asking you the difference between the potential field methods in geophysics and other geophysical methods. So give me my answer the way I have asked you. Please go ahead.
okay, now sorry. The difference between potential field methods in geophysics and other geophysical methods is potential field methods are naturally occurring, while geophysical methods are artificially generated
You see,
energy.
when you say why geophysical methods are potential field methods, not geophysical methods. Williams,
Yeah,
are
ma'am.
potential field methods, not geophysical methods. Yes or no?
Yeah, ma'am.
So you go ahead and rephrase your answer. Please
Potential
go
field,
ahead.
the difference
Yes.
between potential field methods in geophysics and other geophysical methods.
Okay.
The difference is that potential field methods are naturally occurring, while other geophysical methods are artificially generated energy. And those other geophysical methods include seismic method, electrical method, and electromagnetic method. While the potential field method includes gravity and magnetic fields. And those gravity and magnetic fields, they obey the Laplace equation, while the other geophysical methods don't obey the Laplace equation.
All right. Okay. So let me hear your question, then I'll correct something before we go ahead.
Okay, ma, please, what is the Laplace equation?
We'll get to see that. So that's before next class. I need you all to read up what Laplace equation will be. We might have a quiz on that. So in the next class, we'll be starting with the physical principle behind both the potential and the gravity and the potential, the gravity and the magnetic field, magnetic methods. So we'll look
Methods.
at that.
Okay.
Yeah, so it's an assignment to you. Read up what Laplace's equation is. I will get to discuss that better later. So just like I was clarifying, in your definition, you said use other geophysical method. I'm trying to let you know that it is all other geophysical methods, not all of them use artificially generated signals. Just like the telluric method, the telluric method measures the Earth's natural electric current. So that method does not need artificially generated energy. It is under electrical method, but it is not artificial. That is, it is not an active method. So for us to effectively determine or define the potential field methods, what I need you to say is very simple. The potential field methods are measured naturally occurring fields, and they obey the Laplace's equations. While other geophysical methods, they do not obey the Laplace's equation, and most times they are artificially generated. Please take note of the caveat. And not all other geophysical methods that are not potential fields are active. Just like I told you, we have ambient seismic methods. So you have to be very careful about that. I'll try and rephrase this maybe in your notes so that you will not be confused. So the next thing we're expected to do will be the historical development and significance of the gravity and magnetic methods. So this will form your assignment 2. So your assignment 1 is 1. What is Laplace's equation? I hope you are taking notes, class. Assignment 2 will be brief summary of the gravity and magnetic method and their significance. I hope I'm making sense, class. So I need this assignment by next week. By the grace of God, when you're coming to class next week, you should come with this. And the first is assignment on Laplace's equation. You just give a brief explanation of what Laplace's equation is Assignment 2 will be a brief summary of the gravity and magnetic methods and their significance. So would also have that. So with this, I learned that you just have 1 hour. Remember, this is a short class. We'll come to the end of the class for today. I'll speak with your class rep so that we can clarify when next we are going to meet. So do we have any questions for today's class? Any questions for today's class before we call it a day? So in the next class, we'll be looking at, yes, please go ahead.
Please, ma'am, for the assignment, are we going to get a short notebook for it?
No, you could, so that because I have some notebooks from my previous class that is lying fallow in my office, so there is no need. So you could just write in, you could just put them together in a sheet of paper, either typed or handwritten as the case may be, and let me have it. Your name, matric number would suffice. Okay?
Okay, ma'am. Thank you, ma'am.
All right. So in the next class, we will go through the historical development and significance of the gravity method. Then we'll now comment on the fundamentals of potential fields. And in the fundamentals of potential field, we'll be looking at the concept of gravitational and magnetic fields. So what are their basic physical properties? And what is the basic principles that are used? What is the law that governs gravity? What is the law that governs magnetic field? What are the units and the measurement scales? So I hope we should be able to round this off in the next class. Then I'll call on Dr. Oladele to continue with the method. So this is just an introductory method to potential field. So we are not expected to do much, but it is expected for us to, at least it should spur our interest in geophysics. And that's why I have taken out time to give us recent happenings in the field of geophysical measurements and all. So please do not limit yourself to classes or what you have. Read wide, open your eyes and your mind to learning from others and what is happening around. And remember, the essence is to build a well-rounded individual, not necessarily to just come up with good grades. You're graduating in both character learning and character and learning. You should be able to come out tops in that. And as university students, you should be keen to learn. You should be willing to learn. And that's the hallmark of someone that has gone to university. I hope that is clear.
Ma.
Yes, please.
Ma, will we be getting slides on the notes or we'll be writing it like on the board like we doing like in previous?
Writing on the board. Who will write on the board? I'm not going to write on the board for you. We're expected to develop your own notes. Okay? So that is why
Why you?
Who is that person that is laughing like somebody that
It's Nifemi.
Don't mind her. So it's okay. So I'm not writing on the board. I expect you to develop your notes. I'll share my material later. I don't like sharing it now at the end of the class. So I expect you. That's why if I were you, let me share this again. If I were you, I would screenshot this part right now because this is what you're expected to. This is what you're expected to go through. So you screenshot this and develop your materials and read along that line. So the first bullet point is where I'll be concentrating on. So I need you guys to look at that even before the next class. I hope that is clear.
Yes, ma'am.
All right.
Yes, ma'am.
All right then.
Thanks,
so thank you guys for joining in and do have a blessed day. Who was speaking to me on the phone?
Ma'am, good morning.
Covenant. So okay. So I need a list of all those that attended today's class. That's 30. I don't know who is Dean. Who is Dean? Next time you attend my class and you don't put your real name, you just be taken out of the class. And your name should include both your first name and your first name and your your first name as well as your surname. So please take notes.
Okay,
All
ma'am.
right, everyone. Thank you, everyone. And Covenant, do the needful.